Okay, a quick intro to the video I'm about to show you, which is an astounding 30 minutes long. This comes from a California Energy Commission workshop on October 7th of the year 2020, and they are proposing a new prescriptive lighting control that will require acceptance testing by an acceptance test technician. And this is one that they are already familiar with, the acceptance test technicians, because it is the large open office power adjustment factor, which was previously an optional control, but is now going to be a prescriptive control for offices that meet their definition of large open office. So we have a few power adjustment factors for lighting controls. Some of them already require acceptance testing, like the dimming, daylight dimming plus off. We have shut-off controls. This is a shut-off control, and these are required almost under every circumstance, even additions and alterations. So here we see the table from the 2016 code that shows occupant sensing controls in large open plan offices. And you'll note that the power adjustment factor is based on the square footage under control. So let's take a closer look at this. You can take that power adjustment factor and multiply it by the installed wattage, and that will give you something called a control credit in watts, and you can either install that much more or claim you didn't install that much, subtract that off. So 0.4 is a biggie. Here is a 400 square foot office. It's been cut into 4 100 square foot pieces. The idea is that when you enter this section of this large open office, these lights in this section should come on. When you are outside that section, the controlled lights in that section should not come on. We also have this better scheme than trying to control it with one aux sensor in the middle, which isn't going to work worth a hoot, is to surround the area with occupancy sensors that catch the edges and look in. The installation of this power adjustment factor was previously indicated here on the certificate of compliance for indoor lighting, second one, right on the table with all lighting controls. There is previously at least, there had been in the 2016 code, this table to document as an acceptance test technician that they're claiming the correct power adjustment factor and that the thing is working worth a hoot. And there is on the certificate of installation a place to specify that this power adjustment factor is being claimed and that it was checked out prior to acceptance testing and that it is working properly. So, okay, it's a half-hour long video presented by Mr. Simon Lee. The audio may jump up or down when we go to it here, but let's take a look. And you make up your own mind. If you don't like it, put in feedback.
Hello, everyone. My name is Simon Lee from the Building Standards Office. Before I go into the first measure, I would like to thank some of the persons who provide and submit this indoor lighting proposal. They are Marisa Lena, Jasmine Shepard, Christopher Urain, Yao Zhong Wan of Energy Solutions, Bernie Bauer of Integrated Lighting Concepts, and John McHale of McHale Energy. They serve as authors of the non-residential indoor lighting proposal. They will also serve as a panelist during the Q&A session at the end of my presentation. In addition, Jim Banyer and Neil Berger will also serve as the panelists. Finally, I would like to thank those who have provided inputs and supports in the process. There are two measures in the indoor lighting proposal. They are multi-zone occupancy sensing controls for large offices and indoor lighting power allowance. And first, let's go into details of the multi-zone occupancy sensing controls for large offices. A number of sections in the building energy efficiency standards are proposed to be revised for this multi-zone occupancy sensing controls measures. They include section 100.1, section 120.2E3, section 130.1C6D, section 130.1F, section 140.6, table 140.6-A, and table 141.0-F. And in the reference appendix, section NA 7.5.17 and NA 7.6.2.3. This measure is about multi-zone occupancy sensing controls in large offices. Large offices and open plan office could mean differently for different persons. In order to avoid confusions, it is proposed to specify offices larger than 250 square feet as large offices. So what I mean is that offices larger than 250 square feet would be defined as large offices and would have to meet the multi-zone occupancy sensing controls requirements. This line shows several drawings of large offices in different layouts and different configurations. The one on the bottom left is relatively small, and the one on the right is the largest of the three shown. And let me take a minute, and I would like to review briefly current code requirements of occupancy sensing controls for offices. Current code mandates occupancy sensing controls for offices 250 square feet or smaller. And several occupancy sensing types can be used for meeting this requirement for offices 250 square feet or smaller. They include occupant sensors, partial on occupant sensors, and vacancy sensors. Current code does not mandate occupancy sensing controls for offices larger than 250 square feet. And some background about this proposed measure. According to the survey data, current occupancy sensing controls installations usually treat office space as one zone, not multiple zones. The survey also indicates in large office space, occupancy sensors are installed in combinations with time switch controls. Time switch control is also known as time clock to someone in the building industry. And this measure is proposing to have a more granular occupancy control zone, a control zone of 600 square feet, and no greater than that for each control zone. And one benefit of granularity is to reduce the lighting power in each control zone. Besides the 600 square feet control zone criteria for each control zone, the table on the slide shows expected events in each zone and in the entire office space. The middle column shows the expected events in each individual zone. And the white column shows the expected events for the entire space. So let's look at the second row for a minute. The second row, within 20 minutes of non-occupancy in the control zone, the general lighting power in the control zone needs to be reduced by no more than 20% of full power. And then let's look at the next row. When the entire space is empty and unoccupied, within 20 minutes of that non-occupancy, all lights in the large office are required to be turned off. And so these are the essential requirements of this multi-zone occupancy sensing controllers. And this slide shows some more footnotes for the table. Note 1 and Note 2 are for the tables and tells details about those events. And Note 3 is to clarify that occupancy sensor embedded as part of the luminaires are allowed. And then the last note, Note 4, is more or less like a pointer note telling that PAF, power adjustment factor, is available for control zones smaller than 250 square feet. And then this line shows the proposed language for section 130.1C. And I have already covered, I have already summarized the requirements in the previous 2 slides. So I'll just move on and yeah. And the PowerPoints, like we have mentioned earlier, it will be docketed tomorrow. So I'll just move on from this point. Okay. And most likely in any large office space, there are some other lighting controls besides the proposed occupancy sensing controls. And so this slide shows the proposed language for the control interactions. And number eight is about is clarifying the relationship between daylighting controls and occupancy sensing controls. And number 9 is a clarification note for occupancy sensing for HVAC. I'll just touch upon it briefly. When the space is required to have occupancy sensings and the ventilation air is permitted to be reduced to 0 during occupied standby mode, the space conditioning zone shall be controlled as specified in section 120.2E3. And that section 120.2E3 is occupancy sensing control, occupancy sensing zone controls for space conditioning system. And then the following 2 slides will show the language in section 120.2E3. So this is one of the slides for that section, 120.2E3. And this is 120.2E3 is an existing requirements in the section, in the code. And the changes are intended to clarify existing requirements in regards to the applicable occupant sensor ventilation requirements and pre-occupancy ventilation requirements. Those 2 requirements are in section 120.1D2 and D5. In addition, it is also intended to clarify the response time in this section 120.2 and also in acceptance test section in NA. We'll have some more slides for that acceptance test section. And one thing I also want to mention, so within 20 minutes after a space becomes unoccupied, the occupancy sensors shall prompt the space conditioning to go into occupy standby mode. And you will see that occupy standby mode mentioned a couple of times in this presentation. So it's good to keep that in mind. And the next slide will show what happens during the occupy standby mode. So within 5 minutes of entering occupy standby mode, 2 things need to happen. Number 1, the operating temperature should either set up or set back. So this is for the operating cooling temperature and also the operating heating temperature. So that's the number one thing that you should either set up or set back on those temperature. And then the number two things that need to happen is that the airflow to the zone shall be shut off when the temperature is between the active heating and cooling set point. And there are associated changes, proposed changes to the definition of mechanical cooling, mechanical heating, and space conditioning systems. Mechanical cooling. ERV and HRV, they are short for energy recovery ventilation and heat recovery ventilation, are proposed to be not being considered to be mechanical cooling. And then for the mechanical heating definition, this is proposed that systems that only use solar energy or heat recovery as the heat source are not considered to be mechanical heating. And then one more about some proposed changes to space conditioning system. This is to revise or to propose to change heating to be mechanical heating, and similarly propose to change cooling to be mechanical cooling. And this is all for the multiple sensing controls related to the mechanical side or the space conditioning side. And so let's go back to the another section. PAF for occupancy sensing controls in office space, and some background about the development of this part of the code changes. Some stakeholders have suggested to remove the PAF, power allowance factors, as they have not seemed to be being used. And so this proposal suggests to keep the PAF provisions and also to revise and reduce the PAF credit to align with the new multi-zone occupancy sensing controls for large offices. And as mentioned before, open plan office is an ambiguous term to some. And it is proposed to be remove that language open plan office from this code section. And it is replaced by the term, by the definition, office space greater than 250 square feet is qualified for this power adjustment factor. And greater than 250 square feet is the physical size of the office space. And then another proposed change is for the alteration part of the code. It is proposed that the new multi-zone occupancy sensing controls requirements are applicable for the alteration installations when it meets the indoor lighting power requirements of section 140.6. And here are the slide shows the two acceptance tests for multi-zone occupant sensing controls. And one is for the lighting systems, another one is for space conditioning systems. So NA 7.6.2.3.2 is for lighting. NA 7.5.17 is for space conditioning system. And the next two slides will show the acceptance test for space conditioning system. The changes to the acceptance test in NA 7.5.17.2 is to clarify the response time. And the test is also to verify the occupy standby mode, the ventilation before and after the scheduled occupy periods. So that's in a nutshell what this proposed code change would do for the acceptance test. And so this is page 2 for the same acceptance test, NA 7.5.17.2. And so just repeating the highlights again. The acceptance test is to verify the occupy standby mode, the ventilation before and after the scheduled occupy periods. And next, let's look at the lighting acceptance test. There are 4 proposed tests to be conducted on each selected occupancy sensor. They are occupy test, unoccupied control zone test, control zone size test, and unoccupied office test. The occupy test. This test is to simulate an occupied condition in the control zone controlled by the occupancy sensor, and to verify the occupancy sensors can turn on the control lighting. And one important step is to measure the illuminance, as the measurement will be used later for another test. The unoccupied control zone test. This is to simulate an unoccupied condition in the control zone controlled by the occupancy sensor. And 2 things to confirm here. Number 1, the occupancy sensors can uniformly reduce lighting output of the control lighting within a maximum of 20 minutes. And then number 2, measure the illuminance. And this measurement should be no more than 20% of the measurement from the occupy test. And then next, the control zone size test. This is to confirm the control zone size does not exceed the 600 square feet control zone criteria. And 2 methods are proposed here, and either method is acceptable. So method 1 is about taking some measurement and some simple calculations of the detection coverage of the occupancy sensor. And then the second method is could be a simpler in terms of the steps. This is basically about counting the number of zones and then divide the office space square footage by the number of zones. And the calculated area figures must be less than or equal to 600 square feet. And then the last one, unoccupied office test. This is to simulate an unoccupied condition in the entire office space and to verify all lighting in the enclosed space turn off within a maximum of 20 minutes from the start of the unoccupied state. Okay, and we're going to look into the energy savings and the cost effectiveness. And so first, energy savings calculations. There are three model space. We call that Office A, Office B, and Office C. They are all for different size. One is about 2,500 square feet. Office B is about 4,000 square feet. And Office C is about 7,500 square feet. And then these models, basically there are two sets of inputs. The first set of inputs are set up related to the model office with the following parameters. I just mentioned the square footage of the model office, the luminaire layout, the input power of the luminaires, number of occupancy sensors, average workstation or cubicle size, and lastly, number of occupants. And then the second set of input is a time series of occupancy pattern representing the average occupancy. And this is in percentage for the entire office space. So those are the inputs or the assumptions for the energy savings models. The electricity savings for this measure is about 1.025 kilowatt hours per square feet in average for these measuring models. And like I mentioned earlier, there are three office models being studied here for this measure. And the TDV energy savings is about 32.42 kBTU per square feet in average for the measure models. This slide shows the labor and material cost information used in the cost effectiveness analysis for this multi-zone occupancy sensing controls for large offices. This table, it shows the cost effectiveness and also summarize the incremental so the so the benefit to cost ratio is 1.26, and so the measure is cost effective. And this slide shows the expected benefits of implementing the measure in the first year when the requirements are in effect. The annual energy savings is expected to be 62.44 gigawatt hours, and the annual cost savings is expected to be $176.28 million. In addition to the energy and cost savings, the other benefit is that the measure aligns with the IECC 2018 requirements for occupant sensor control function in open plan office areas. This requirement is similar to the occupancy sensor functionality for open plan office of the IECC 2018 code. About the greenhouse gas emission reduction impact, the annual greenhouse gas emissions reduction is estimated to be 15,103 metric tons metric tons of greenhouse gas. And let's look at the technical feasibility and cost effectiveness. First, technical feasibility. Occupancy sensors and lighting controls for meeting the proposed requirements are commonly available in marketplace. There is relatively new approach of placing the occupant sensors at the luminaires, also known as luminaire level lighting control, LLLC. The benefits of this approach is an increase of granularity of the control area. If the control decision of the luminaires depends on the luminaire sensor detection. Also note that network lighting controls, wireless controls, digital controls, and luminaire level lighting controls are all allowed to be used as part of this approach to provide for meeting the multi-zone occupant sensing controls in large offices. And for cost effectiveness, this proposal is expected to be cost effective in all climate zones and for all building types. And that's all for my presentations. And I'll stop here and open the floor for any questions.
I don't see any raised hands, but oh, we got one raised hand. Sorry, Charles. Please, when I mute you, you have to unmute yourself, but state your name and affiliation, please.
So Charles Kanufke with Wattstopper. I'm trusting you can hear me.
Yes, perfect. Go ahead.
Thank you very much. I just wanted to say appreciate the work that's been done on this for the multi-zone occupancy sensor approach. What I particularly appreciated was the feedback that the team who were putting this together sought from the industry at large, and the availability of the pre-draft report for us to provide some suggestions. The original language I thought was going to include some things that, some lighting types that necessarily might not really be appropriate, and really wanted to make sure that we did line up with the IECC language and making sure it was general lighting only being controlled. And so I want to say that not only did we get that reconciled in the final report, I also want to say that I really appreciate that during that session, we were talking about the misunderstanding about what was going on with the HVAC integration with the occupancy sensors. We had been given feedback from the CEC originally that 5 minutes was basically demanding a 5-minute time delay for the occupancy sensors. And it was during that meeting that we actually realized, no, the actual intent was that after the sensor detects no occupancy and goes unoccupied, the 5 minutes was a grace period to allow the HVAC equipment to appropriately come up to speed and provide the ventilation. So it was really a great opportunity to work with the case team, and you never know what you find out when you get committed people talking and trying to understand each other's problems. So I just wanted to say that. Thank you very much.